So today we're going to be looking at some of the proofs in section 9.3, so pay attention to where we are if you have the notes printed out. But today we're going to be looking at proving that a quadrilateral in a coordinate plane is a parallelogram. Okay, so there's a couple ways that we can go about doing this. To prove it's a parallelogram, there are a couple things you could do. The first thing you could do is use the distance formula to prove that opposite sides are congruent. So if you don't remember, the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Second option, use the slope formula to show that opposite sides are parallel. Okay, this should say sides, by the way. So the slope formula, if you don't remember that, it's rise over run, or y2 minus y1 over x2 minus x1. Okay? Now our last option is to use midpoints to show that the diagonals bisect each other. So if the diagonals have the same midpoint, then that means that they bisect each other. So the midpoint formula is x1 plus x2 over 2, comma, y2 plus y1. I mean, it doesn't matter, but y1 plus y2 divided by 2. Okay, and that'll give us our midpoints. Now, if we want to prove that something is a rhombus, we have to show that it's a parallelogram first. And then we use the distance formula to prove that all sides are congruent. Okay? So remember, if you're proving something is a rhombus, you have to start with the fact that it's a parallelogram first. Okay, so moving forward, I'm not going to talk about the rectangle, proving something is a rectangle today. I'm just going to keep going with the rhombus and parallelograms. So let's start with this problem we have here. So we have to prove that the quadrilateral whose vertices are at points A, B, C, and D is a parallelogram, and it gives us all the points right here. So we're proving it's a parallelogram. So we have a couple options like we went over as to how to do this. For this example, I am going to use midpoints to show that the diagonals bisect each other. I think that is one of the easiest ways to go about this. So one of our diagonals is BD, right? And we have to find the midpoint of that. So B is negative 3, 4, and D is at 3, 2. Right? So we said that to find the midpoint, first we have to find the average of the x's, so x1 plus x2 divided by 2. So negative 3 plus 3 divided by 2. And then we have to find the average of the y's, so that'll be 4 plus 2 divided by 2. And we end up getting 0, 3 as the midpoint for BD. Now we have to look at CA, because, right, CA right here, that is the other diagonal. So CA, to find the average of the x's first, we know that A is negative 1, 1, and C is 1, 5. So the average of the x's will be negative 1 plus 1 divided by 2, comma, the average of the y's, 1 plus 5 divided by 2. And we get 0, 3, which, as you can see, those are both the same for BD and CA. So therefore, all we have to say is that quadrilateral A, B, C, D is a parallelogram because the diagonals bisect each other. Alright, so that's one option on how to do this. Okay, so moving on to the next parallelogram problem. It says that quadrilateral DEFG has these vertices. Prove that it is a parallelogram. So why don't we go ahead and label our points first. D, 3, 4. E is 8, 6. F is 9, 9. And G is 4, 7. Alright. I am going to use the same method I did the last time. Midpoints, they're just easy, honestly. So whatever works for you, but this would be my suggestion. Okay, like we said, there are 3 different options for how we approach proving a parallelogram. So let's start with DF right here. Let's find the midpoint of that. So we have to find the average of the x's. So 3 plus 9 divided by 2. And the average of the y's will be 4 plus 9 divided by 2. And we end up with 6, 6.5. Okay? Moving on, let's look at GE, right? That's our other diagonal. So GE, average of our x's would be 8 plus 4 divided by 2, and our average of our y's would be 6 plus 7 divided by 2. And we end up with 6, 6.5, which, like we said, is the same as our other diagonal, which means that they do bisect each other. So, all we have to do now is write it out. Quadrilateral DEFG is a parallelogram. And we said it is because the diagonals bisect each other. Okay, remember that you can't just write this and you can't just show your work. You have to show your work, prove that it works out mathematically, and then write a statement of what that math means. So yes, here we proved that it works out mathematically right here. And then we said this math shows us that the diagonals bisect each other, therefore this quadrilateral is a parallelogram. Okay? Moving on. I'm not going to go over this today because this is a rectangle. Like I said, I want to talk about rectangles in the next video. Alright, so moving on, I'm going to look at this problem here. I'm going to skip this rectangle one above it for now. We'll go over that in tomorrow's video. So it says that we have this quadrilateral, QRST, and we have to prove that it is a rhombus. Alright, so remember, when we said when we're proving something is a rhombus, we have to start and prove that it is a parallelogram, and then we have to go back and prove that the sides are all congruent using the distance formula. So let's start with proving it's a parallelogram. Now, usually I would go for the midpoint formula to show that the diagonals bisect each other, but one of our options for proving that something is a parallelogram is to use the distance formula to show that opposite sides are congruent. So already I'm using the distance formula to show that opposite sides are congruent, which is one way to prove a parallelogram, and then to prove a rhombus, I'm using the distance formula again to show that they're all congruent. So instead of proving it's a parallelogram by doing the midpoint formula, I'm going to use the distance formula this time, and by showing that they're all congruent, I'm proving that it is a parallelogram and it's a rhombus at the same time, which makes my life a lot easier, right? So, distance formula, let's start with QR, right here in blue. Right, Q is 6, 7, and R is 11, 7. So the distance is going to be the square root of 6 minus 11 squared plus 7 minus 7 squared. Alright, this gives us the square root of 25, which is 5. Okay? Let's look at our s. Right here, I'm labeling it in green. We know that s is 8, 3 also. 8, so this is rs. So, square root of 11 minus 8 squared plus 7 minus 3 squared, which, guess what? Square root of 25, which is 5. Okay? So already, we have that two adjacent sides are congruent. Now, we want the other two to be congruent as well. And that will answer our proof. Okay, moving on. Let's look at TS right here. TS, and we know that T is 3, 3. Alright, so square root of 8 minus 3 squared plus 3 minus 3 squared. That is the square root of 25, which, guess what, gives us 5. So already 3 out of our 4 sides are congruent. All we have left to check is QT. Let me use a different color. I'll use yellow, QT. So QT, we have to do the square root of 6 minus 3 squared plus 7 minus 3 squared, which is the square root of 25, which is 5. So, by doing this, we proved that it is a parallelogram and it's a rhombus at the same time. 2 birds, 1 stone. Makes life a lot easier. So, all we have to say now is that quadrilateral QRST is a rhombus because all 4 sides are congruent. Okay? And that's it for that one. Alright, moving on. This orange right here is the last one I'm going to go over today for parallelograms and rhombuses. Alright, so it gives us quadrilateral RHOM, and we have to prove it's a rhombus. And remember, we said we have to prove it's a parallelogram first, and then it's a rhombus. And to prove it's a rhombus, we prove all 4 sides are congruent using the distance formula. And we can prove it's a parallelogram using that same process. So all we have to do is the distance formula for all 4 sides. Right? So when it says prove something is a rhombus, automatically distance formula all 4 sides. Okay? So let's start with RH right here in red. R is -3, 2, and H is at 2, 4. So RH, square root of -3 minus 2 squared plus 2 minus 4 squared. And that gives us a square root of 29. I'm going to leave it like that. I'm not going to write it as a decimal because I should get square root of 29 for every single side. Okay, so now let's look at HO. Use a different color, HO in blue. O is 0, -1. So, segment HO will be the square root of 2 minus 0 squared plus 4 minus -1 squared. And guess what? That gives us 29. So, off to a good start. Let's look at OM now. OM is at -5, -3, by the way. So, OM, and we get the square root of 0 minus -5 squared. If you want to write 0 plus 5, it means the same thing, doesn't matter. Plus -1 minus -3 squared, and we get the square root of 29. Finally, let's look at Rm here in yellow. So Rm will give us the square root of -3 minus -5 squared plus 2 minus -3 squared. And we get square root of 29. And that's it. All we have to do is write our concluding statement. So quadrilateral RHOM is a rhombus because all 4 sides are congruent. And that's it. So do your Google Forms attached to this. If there's a way, let us know if there's a way that we could better make the Google Forms work. We're kind of trying to figure out how they work best in how to do proofs, these types of proofs best in a Google Form format, because there are so many ways to prove it. So kind of figuring that out. But you should be fine. You shouldn't have any problems. Just remember, you have multiple options if you're just proving it's a parallelogram, but if it's a rhombus, I would just telling you, I would go for the distance formula for all 4 sides every time. All right? That's it.